Okay, so today we're going to go ahead and do 5.4, but before we do, I wanted to um, do one of the problems from the test. And RJ and Emma, should have that one in your email by the time we get started. So anyway, I wanted to go over the very last problem, which is number 13, and it was going to be the exponential decay for the half-life problem. We are going to have one like that on the test. And so what I wanted to, for your final, so I wanted to make sure we go through this one again and just kind of remind you how to do this. Some of you did okay on the first one. Let me start with the number 12 because it doesn't use as many steps, but you're going to use the function or the formula A equals A sub odd e to the kt power. Now, to identify each of the parts, the A is going to be your initial, A sub odd is going to equal your initial amount. And then A is going to be like after you either grow or decay, it's going to be the amount that it finishes with. K is going to be your rate, and then T is going to equal your time. So in the very first one, like on 12, to set this one up, if you go, it says complete the table of the population growth model. If you start with 43.6 million and then you end up with 57.5 million, your starting amount has to be the 43.6. Then I'm going to end with an amount of 57.5. So again, it's going to grow. Then we're going to end up with E to the K. And in this case, we're saying we're looking for the value of K. So that's our missing amount. But we also are kind of subtly given the time because it says on the chart, you start off with 2007 and you go until 2037. And so that means time has to be then 30. In order to do this, this is multiplying. So that in other words, to get the 43, I want to isolate the E to the KT power first. So I want to get rid of the 43.6. And remember, if it's multiplying here, they're going to do the opposite. So I'm going to divide both sides by 43.6. And so then I'm going to end up with then the 57.5 divided by the 43.6. And that's going to give me 1.318. I'm just going to do enough that I can tell what it is on my calculator. Then what I have left is going to be E to the K times 30 power, which I'll write as 30K. The next step, and this is the most important one from this set lesson, is that now we're going to take the ln of both sides. And as long as we do both of them, we're not breaking an algebra rule. So I'm going to take the ln of 1.318 is equal to the ln of E to the 30K power. Whoops, as I write 3K. So the ln of E of the 1.3, I can go ahead and grab my calculator. I'm going to hit my ln button. I'm going to select the 1.3. And that's going to have a value of 2.2767. On this side, if I have the ln of E to the 30K, I know with my power rule, that means that I'm going to be able to bring that power right out in front. And I can write this as 30 times K times the ln of E. Now, from the very first, like on our first page, remember the ln of E, since it's the log base E of E, anytime your base and what you're taking the log of is the same, this value is going to change just to 1 because the ln of E is 1. So now I have then 30K is equal to 0.2767. Remember, times 1 is not going to affect it. And so then I will just divide by sides by 30. So my value of K would be the 0.2767 divided by 30. And that's where I end up with 0.0092 is equal to K. Now for my second problem, it's a little different. It's going to have the same kind of formula. We're starting off with the same A equals A sub aught e to the KT power. But the trick is on a half-life, you don't have to actually know the exact amounts of your half-life. You just know that whatever you start with here is going to be 1/2 of this one. So in other words, if I think about it, I'm going to write it as 1/2 A sub aught is equal to A sub aught E. And then I know I need to find K first. And I'm given that the half-life is 120 years. And so that means that I'm going to have then a 120 times then my K. And I need to find K. Now, what happens then with the A sub aught is that they both just cancel out. And so I end up with just 1/2 equals E to the 120K. Now what I want to do is I want to go ahead and I want to take my ln of both sides. And in this case, because I'm getting smaller and it's decaying, I should get a negative number. So if I have the ln of 0.5 or 1/2, I get negative 0.6931. And then I'm going to do the same thing here on this one. I'm going to take 120. It's going to move out in front. After I guess I have to take the ln of both sides, ln and the ln. So I'm going to have the 120 times K times ln of E. And the ln of E then just changes to what again? 1. Yep. So then I have then negative 0.6931 is equal to 120K. So that means I need to divide this by 120 to find my K. So then a K then is going to equal negative 0.00577. After I get that one, they want to know the second part, and this is why I let this one be worth another point, is because I need to go ahead and substitute it back in, and they want to know what is the substance decay going to be until I get 75% of the original amount. And so what I need to do, I found the value of K from my half-life. My second part of it is now going to be changed, that I'm going to go then 0.75 times my A sub aught, which is my original amount, is equal to A sub aught. E to the now K is going to be the negative 0.00577, and then I'm going to take it times my time because I don't know how long it's going to take to get to 75%. And just like I did before on the half-life, my A sub aughts cancel out, my initial amounts cancel out. And then I'm left with then 0.75 is equal to E to the negative 0.00577T. And this is when, since I'm looking for T and it's in my exponent, I'm going to take the ln of both sides. So I'll have the ln of 0.75 is equal to the ln of E. And this amount here is just going to go out in front. So let me even move it over, squeeze it over first, because I'm going to have it as a power. So I have the negative 0.00577T times the ln of E. And the ln of E, just like it did before, is going to change to 1. And I can take my calculator and find the ln of 0.75. So the ln, let me go. The ln of 0.75 should be then a negative 0.28768 is equal to the negative 0.00577T. And so I'm going to take this amount, my ln of 75, I'm going to go divided by, and I'm going to come up until I find where I had the 0.00577. And I'm going to hit equals. So my T then is in equals then 49.8 years. And this is where if you can arrow up and grab those, you've noticed I kept it to the 5th decimal place. the more decimal places that you can keep it to, the more accurate your problem's going to be. Because this is, again, anytime you have E is going to be, anytime you take the natural log, you're talking about E, which is also an irrational number, just like pi. And so it's never, the longer the decimal places that you can carry it out to, the more accurate you're going to be. And you have less error maybe with your rounding. So I just wanted to go over that problem. Look, I'm going to leave you guys with hopefully that it'll make sense once you get your homework problem. I'm going to see if I can make that just a little bit bigger. Your test back, I did go ahead and try and write kind of why we missed it. And so if you have any questions though, please holler back at me. So today we're going to go into 5-4. And in 5-4, I'm also going to go ahead and ask you to look under the Desmos. And I put in our, let's see if I can, this is my struggle finding it now. I know, sorry. All right, so there it is. Okay, so in our lesson plans, so under the lesson plans for college algebra, I went ahead and I've given you a video link. So right here under Thursday, there's a video link for Desmos. And if you click on that video, that link, it'll actually put all of the expressions that we're going to talk about today. It'll have them. You'll see it when we start, because the very first two are the problems that we start with. But before I get going on our lesson, okay, so again, let me move this over so that I can see both my my screen and my Desmos activity. So on my Desmos activity, I went ahead and put the functions in just because I think it's important for us to understand what the graphs look like. And so I'm going to have you play with this just a little bit. Now, the very first one, notice I went ahead and put is the second function on my equation right here. And today what we're going to do is we're going to find the systems of equation where it's the solutions. Now, just like we did yesterday with two linear equations, we found that when the solution actually is where they intersected. Well, it's going to be the same thing for this one on two nonlinear systems. And so the very first one, I know that 2x plus y minus 5 is going to equal a line. And I'm going to go ahead and unshade it and then put it in. I know that to be the case. And I need to add in a -5, don't I? Tell me what properties. Why did I know that it was 2x? 2x plus y equals -5 is going to graph as a line. What clue? What do you notice about it being different from this one? Right, it's that's the power. So if you notice, the x is to the first power and the y is to the first power, and there means that they're always will graph as a line. So anyway, this is called a first degree equation. The second one, if I could actually put in, let me show you on Desmos, you can put just the function, or you can also, like, in other words, it's assuming it's going to be y equals. I could have written it as y equals x squared plus 6x plus 7, and that's still going to give me my same function. Tell me why you knew that one was going to be a parabola. X squared. Now, keep in mind, the y is to the first power, but the x is going to be to the second power. And so that would be a parabola. If I switch them around, in fact, let me just unselect these two, because you can kind of play around with, I love Desmos because you can do so many things with it. But let's say that I have a y squared, and then I'm going to go then minus x equals 2. Okay. Notice that when my y is squared, then I have a parabola, but it's opening to the left or the right. If I make a negative in front of that, then it's going to open to the left. And so again, that one would not be a function that we had, but that's going to show you that when you're squared, one is squared and one is not squared, you're going to have a parabola. And if it's the x squared, then you're going to have a parabola that either opens up or down. So let's go back to the two problems that we have. So we start off with a line. And then we also have a parabola. And we're going to show how to solve these equations both algebraically, but also I wanted you to give an idea on what you're going to get with graphically. So look at this problem here. So obviously I'm going to have, in this case, when I put it in, I'm going to have two different solutions. And I can find those by just clicking on those values. But imagine my line was a little bit different. So let's say that I happen to be, that my line happened to be maybe minus 15. What solution would you come up with if you had this line instead of the one that we were given? No solution, exactly right. And you can imagine also there's a possibility that you would just get one solution because if it just was a tangent. Okay, so let me go back to the original. So we know when I graph it, so you're going to be able to, if you want to open your Desmos when you're doing these problems, you might want to graph your or put your two functions in just to kind of see what you're going to, how many functions, how many solutions you're probably going to find. But now in this one, let's go ahead and just, we're going to solve it. Now, again, if you notice, I can substitute or I can eliminate. They've asked us to go ahead and use the substitution method. So if that's the case, then I've already have this one solved for y. So y equals x squared plus 6x plus 7. So that means that on my equation, 2x plus y equals a negative 5. That means that this y can be replaced then with x squared plus 6x plus 7. And then I have an equation that's only in terms of x. So I'm going to drop down my 2x. But then I'm going to go ahead and replace my y with x squared plus 6x plus 7 is equal to negative 5. Now, when we've had quadratics before, the first thing we do is kind of simplify. We're going to combine our like terms and set it equal to 0. So I'm going to start off writing it in descending order. So I'm going to put my x squared first. But then I have 2x plus 6x. That would be the only x term. So 2x plus 6x would be then 8x. And then I'm going to add my 5 to both sides because I want to set it equal to 0. So I have then plus 12 is going to equal then 0. Now I have choices on this one. I could go ahead and factor. I could use my quadratic. I could complete the square. Probably wouldn't choose to complete the square, but you could. But in this case, I'm going to say factors of 12. I always look to see if I can factor first. Factors of 12 that add up to 8. Can you think of two factors that multiply together to give you 12, but add up to 8? Yes, 2 and 6 is the correct answer. And I know that because I'm adding them and this sign is positive, that means both of my values are positive. And so that means x is going to equal a negative 2 or a negative 6. Going back to my Desmos, that's exactly what I found right here and here. But I also want to find that coordinate. And so to show it algebraically, I'm going to go back up and I'm going to use my equation 2x plus y is equal to negative 5. And I'm going to replace my x with negative 2 and then again with negative 6. So 2 times negative 2 plus y is equal to negative 5. And negative 2 times negative 2 is negative 4 plus y is equal to negative 5. Add my 4, y then is going to equal then negative 1. If x, let me go ahead and put a little dot here. I'm going to also let x to equal negative 6. So I'm going to go 2 times negative 6 plus y is equal to negative 5. In this case, I'm going to have negative 12 plus y is equal to negative 5. Add my 12. And then y should equal then 7. So that tells me I have two coordinates. I have the coordinate when x was equal to negative 2, so it's going to be negative 2 comma negative 1. And I also have, let me put an and. I have then my other solution when x is negative 6 comma 7. And that's also what I found when I put my equation in. Make sense? So let's go to the next one. Again, I think it's good to know before I click on my next button, you have an x squared and a y squared. A guess? Circle. So a circle will be when x squared and y squared are both there, and they're both positive. I'm going to show you one that's not. So in just a second, but This is going to give me a circle anytime. And remember when we did circles, that was going to be, in this case, of it was circles are in the form of, let me go CIR, x minus h expression squared plus y minus k expression squared is equal to r squared. And we had that from a previous lesson. And so in this case, this is going to be, my circle is going to have a center of 0, 0, and it's going to have a radius of the square root of 5. My second one is 3x minus y is equal to 5. What do you think what is that one in graph as? A line. Very good. And so when I click on that, you can see that on this case, I'm going to have two solutions. I could also have 0 solutions. Okay, let me just change it to, let's go ahead and go -5. I think, oh, nope, -5. Let me go -15. How about there? That would be a no solution. So then you could also have them where it just touches once, and that's going to be then your tangent. That would be harder for me to actually try and guess, but let's go ahead and just do this. So I know I'm going to get two solutions. It looks like they're two whole solutions, but let's go ahead and do this also graphically. So in this case, I'm going to go ahead and solve one of my equations for y. Now, when I look at the x squared and the y squared, I'm not choosing those two because I'm going to have to take the square root if I can. But on the other one, my line, I'm going to say, okay, is there which one would be easier to solve for? And hopefully you see, because there's not a there's the leading coefficient for the y is -1. That's the one I want to pick. So I want to manipulate this. So I have 3x minus y is going to equal then 5. And I want to solve this equation for y. So in other words, I'm going to move the y to the other side, but I'm also going to move my 5 to this side. So in this case, I'll keep it as y equals 3x minus 5, which should be the same as y equals 3x minus 5. So both of those are saying the same thing. So once I have it set equal to it, then that means I can go back to my original equation of x squared plus y squared is equal to 5. And y now is going to change to 3x minus 5. So that means I'm going to come right over here to my y squared. I'm going to go x squared because it's going to stay. But then I'm going to go plus. I'm going to change my y squared to 3x minus 5. But remember, it's also squared is equal to 5. Once I get it to here, I need to expand this out just a little bit. So I'm going to go x squared is dropping down plus, I'm going to take 3x minus 5 times 3x minus 5. So over here to the side, if you want, write it out and then FOIL it. Okay, so 3x times 3x would be then 9x squared. Good. Then I'm going to end up with 3x times a -5. And that would give me then a minus 15x. But then I'm going to also have -5 times 3x is a -15x again. And then my last term, -5 times -5. So plus 25 is equal to 5. And I'm going to start combining some things. So I have x squared plus 9x squared would be 10x squared. I have 15x plus 15x would be a minus 30x. And then I'm going to move my 5 over, subtracting 5 gives me then plus 20 is equal to 0. Now, to get I'm going to take care of, I don't want, if you notice, I have a 10, I have a 30, and I have a 20, all are factors of 10. So I can just I can divide both sides because 10 divided by 0 divided by 10 is just going to be 0. So I'm going to end up with x squared minus 3x plus 2 is equal to 0. And now I'm going to factor. So I'm going to say factors of 2 that add up to 3. Well, you probably would guess 2 and 1. And notice since we're adding them, this sign is negative, that means both of these are negative. And so my last step for x, I'm going to say x is going to equal 2 or 1. If x is equal to 2 or 1, then I'm going to go ahead and put it back in and find y. So then y is going to equal, when x is 2, 3 times 2 minus 5. And 3 times 2 is 6, minus 5 would be then just 1. And then, y equals 3 times 1 minus 5. And 3 times 1 is going to be 3, minus 5 would be a -2. So that means my solutions then were x is equal to 2, y was equal to 1. And when x was equal, I can't, when x, my paper keeps moving on me. When x is equal to 1, y was going to be negative 2. And that's exactly what we found before. So I do want you to solve them algebraically, but I also want you to use your tool to kind of make sure you're getting the right answer and also to help with just the next part. All right, I've got my next one. And notice it's a little different. It has a minus in front of it. You have a guess. This is probably one we haven't had. This is called a hyperbola. And a hyperbola means that they're going opposite directions. It's like two parabolas maybe like put together, but a hyperbola will always have one of your values negative. Now, again, this is the one that's on the homework problem, but just let me show you what happens if I change this to a minus and I make the y then a positive. Then I have a parabola that opens the other direction. So if you're in this case, if your x is going to be negative, that means you're going to be opening up and down. If your y was going to be negative, like we have on the problem, then you're going to have left and right opening. Okay. So imagine now the next one, it looks a little bit like a circle, but because of the coefficient in front of it is they are different. In other words, I have a 4x and I have a x squared, but I have a 1 y squared. Because the 4 and the 1 are different, you end up with an ellipse. So in this case, those are my two values. And if you look in this case, I'm going to end up look like I have just two solutions, but how many could I have? Yeah, I could have 4. So in other words, if I change this one, even if I go to 9, nope, so I want to go less. I'm going to go to 2. That's one that would give me 4 solutions. Okay. So it's this one again. We're going to change it back to what we have. So this is our function. This is our problem. And this time we're going to go to we're going to go to algebraically and we're going to solve the same thing. And they ask us to do the addition methods, which again, I call elimination. So in other words, all I have to do is take this, and in this case, because I have a negative y squared and a positive y squared, they're already going to cancel. I don't have to do anything with it. But I am going to add them. So I have 4x squared plus 4x squared would give me 8x squared. Good. And 4 plus 4 is going to give me 8. Then I'm going to end up dividing both sides by 8. So I have x squared is equal to 1. Now here's the kicker. When I take the square root of both sides, okay, remember, x is going to equal not just 1, but both positive and negative 1. So we have to remember that that's a possibility. So when x is equal to 1, I'm going to substitute it back into one of my equations, and I can pick either one. So let's just take the second one. So I have 4x squared plus y squared is equal to 4. If I substitute 1 into my equation for x, I'd have 4 times 1 squared plus y squared is equal to 4. Then 4 times 1 squared is going to be 4 minus 4 from both sides. So y squared is going to equal 0. And I'm going to take the square root of both sides. And so y is going to equal then 0. Notice on this one, this is where we had gotten 4 solutions, right? If it had been anything else other than 0, like if I had solved here and I had the square root of 4 here, then I would have both a 2 and a negative 2. So that's where you would come up with 4 solutions. Because it's just the square root of 0, that's why you're ended up with the 2. But remember when I substitute negative x into this, so I have 4 times negative 1 expression squared plus y squared is equal to 4. This is still going to change it to a positive 1. So I'm going to have 4 minus 4 again. So y squared is going to equal 0 again. So again, y is going to equal 0. That's kind of the reason. So you have the solutions at 1 comma 0, and you have solutions at negative 1 comma 0, and just 2 of them in this case. But remember, you could get possible up to 4. Okay, the last group that I have before I have, okay, x to the third plus y equals 0. We've had the x to the third equations because remember they go opposite. Notice that you're always going to have at least some solution, or it's going to cross the x-axis when you have an x to the third or any odd equation. So in this case, if I go here to my second one, x squared minus y squared, that's going to give me a parabola. So it looks kind of crazy, but there is a solution in here somewhere. So at 0, 0, I have, it looks like it's, let me even zoom it up. You can kind of tell right there if I can zoom. Looks like I'm probably going to get a 0, 0 as my solution. But if this had been moved in any direction, let's say that I had, if I go +4, notice that on this case, yeah, maybe I zoomed it out so much. You can see that I could have two solutions. Okay, I could have multiple ones. So let me go ahead and go back to our original problem. This one was 0, and we're going to solve it algebraically. So again, solve the system by any method of your choice. Now, in this case, if you notice, I can add and use elimination because my y's will cancel out pretty darn easily. I could also solve for one and substitute it back in. So if I do that, let me go ahead and just add these equations. I've got to be careful because x to the third plus 2x squared, I can't just say that that's going to be 3x to the third. They're not like terms. So I've got to write it as x to the third plus 2x squared because that would be the solution. My y's do cancel out, and then I go 0 plus 0 is going to be 0. And so in this case, all I'm going to do is I'm going to start off by factoring out my x squared, and I end up with then x plus 2. So x in this case is going to equal 0, or it could be -2. Now notice on this one, when I did, I thought, oh, great, I've got the 1, 0, 0. But algebraically, I've got an issue because at -2, I also have a solution. And so you got to be careful when you're doing your graphs, because when you zoom in, there could be something that's hidden back there. And there is certainly one right there when I get to 2. See if I can find 2. 2 is going to also be a solution where it graphs. And so I can pull it down and zoom it in if you want to kind of show, but that one's when they're pretty, I mean, they're almost the same steepness. And so it's hard to kind of determine where the solution is. And so that's where algebra comes in, and it works out perfectly. So now we can tell. So now in this case, I've got x is equal to 0 or x is equal to -2. So I pick one of my equations and I'm going to substitute it back in. So I'm going to choose x squared minus y is equal to 0. And I'm going to put x in there. So I'm going to first let x equal 0. So 2 times 0 squared minus y is equal to 0. Goodness, 2 times 0 is 0. So I have 0 minus y is equal to 0. I've got a lot of zeros there, but y is going to equal 0. There's my point, 0, 0. But I also want to let x equal a -2. So 2 times -2 expression squared minus y is going to equal 0. This is not going to give me that. So I've got -2 squared is going to be 4 times 2 is going to be 8. So I have then 8 minus y is equal to 0. I can move my y to the other side, but if you move your 8, you remember you have to keep that negative. So minus y is equal to -8. And that's why you get a +8 is your solution. And so that's where I'm going to end up with. And my second solution is -2, 8, +8. And it shows with me graphically too. Make sense? Awesome. All right. In this case, we're going to have a couple of story problems, okay? And the area of a rug is going to be 108 square feet. The length of its diagonal is going to be 15 feet. Find the length of the rug. Now you have actually two equations that's hidden, but what I would always suggest, start by drawing a picture. Here's my rug. Okay, in this case, and I also am given that the diagonal is going to be 15 feet. So the diagonal I'm going to draw in is here is going to be then 15. Now, in this case, I'm going to have a length and the width. And so what you define, you can either use X and Y, you can, let's go ahead and just do the length. I'm going to do a lowercase, I'm going to like a cursive L and a cursive W. That's going to be my length. I have two formulas because I'm also given the formula for area of my rug. And area is found by doing what? What's their formula for area of a rectangle? It is length times width. So I'm going to just go W here. And then I also, because of the fact I have a diagonal, I also can think about this as my Pythagorean theorem. And my Pythagorean theorem says I have if a squared, if I have a right triangle, which I have a rectangle, so I do, a squared plus b squared is going to equal c squared. And so using my values here, I'm going to substitute those back in. So that means that w squared plus L squared is going to have to equal 15 squared, which is my hypotenuse. On this one, I can change that. I am given that the area is equal to 108. So now I can replace the area right here with 108 is equal to length times width. Now I'm going to go ahead and choose. I have two equations. I have this equation and this equation. I've got to either use substitution or elimination, but because of the fact that this is multiplied, and that would be one term, addition or elimination would not be a great choice, but substitution is going to work great. So I'm going to solve for one of my equations. So one of them. So let's go ahead and say I'm going to solve for L. That means I want to divide both sides by W. So L is going to equal 108 divided by W. That means I can substitute that in to my L squared over here. So I'm going to start off here with W squared plus, and then I'm going to change my L squared. It's going to change to 108 over W is equal to then to 15 squared. And I can go ahead and write that as 225 or write it as 15 squared. We're going to start simplifying. I am going to grab my calculator because I don't know what 108 squared is. So let's find it. 108 squared is going to end up being 11664. So it would actually be 11,664. But then I have W squared. And I also have the W squared here equals the 225. Now, in this case, W squared is on the bottom, correct? So remember when we did rational expressions, I want to get rid of that W squared. I don't want it on the bottom of my fraction. And I can do that as long as I multiply both sides of my equations times the same thing. In other words, I'm going to multiply this side times W squared, and I'm going to multiply this side times W squared. Well, when I distribute, the first one is W squared times W squared. That's going to be W to the fourth. Good. But then my next one, when I take it times this term, my W squareds are going to cancel, which is what I want. And I'm left with just that 11,664. But on my other side, I have 225 times W squared. I'm going to double check. I'm pretty sure. Yeah. Okay. Sometimes I'm not totally confident on my squares. So the next one, I'm going to go ahead and set it equal to 0. Even though I have a W to the fourth, I'm going to move this 225 W squared over here. So I'm going to go minus 225 W squared. And then I'm going to have plus 11,664 is going to equal 0. Now, in this case, I've really got this quadratic, but instead, this is where we let U equal W squared. And so this would be then U squared minus 225 U plus 111,664. And I've got a quadratic. I've just got to remember when I finish, I'm going to substitute them back in. So in this case, I'm going to go ahead and I could look for factors of 11,664 that add up to the 225, or I could go ahead and jump it into my quadratic. So I'm going to go a minus 11,664 plus or minus the square root of 11,664 squared minus 4 times A, which is 1, times C. Whoops. That's B. Hold it, cross out. 225 is my B. And then this one, a minus B, plus or minus. Goodness gracious. So this is going to be a plus 225. But then my 4AC, which is going to be 11,664. All over 2 times A, which is going to be 1. Okay, so grab your calculator. 225 squared minus 4 times, I have 11,664 in my calculator. I'm gonna get then 3,669, and then I'm gonna take the square root of it. And I get 63. So I have 225 plus or minus 63 all over 2. So if I go 225 plus, not times, plus 63, I'm trying to hurry because I'm running out of time. I got 288 divided by 2, so it'd be 144. But if I have 225 minus 63 divided by 2, I get 81. So what happens is then it's going to actually work. When I do this, I remember I have to have that this is going to equal. So I have W squared is equal to 144 and W squared is equal to 81. That means W is going to equal plus or minus the square root of 144, which is 12. And also W is going to equal the square root of 81, which is going to be plus or minus 9. Now, if you're talking about a width, can we eliminate one of them? Yeah, it can't be negative. So that means my width could be 12 or it could be 9. If it's that way, remember my length is going to be the opposite. So in other words, it's going to end up being my rug is going to be then a 12 by 9 rug because when I substitute it back in. Whew, we got it. Stop sharing and